So complexity of the priority queue again. So in the first part of this week, we already covered this case. For example, unsorted implementations takes to build this order of n. But sorted implementation, because it's always sorting, it will take order of n squared time, right? And in queue process, it takes order of n. In the queue process, this will take order of n, right? And then in queue process is order of 1 and order of 1. The queue process is order of 1. And the bind max is actually same to this DQ process, right? So this is the same, right? Good. So, but binary heap, by utilizing the binary heap, what we can do is here. Reference-based structure, which we didn't discuss here, is very similar to the array-based approach. So, if we look at this array-based knife build approach, the build time is just order of n log n because it is going to insert n items with log n complexity. So in Q is order of log n because it will take log n percolate up, and deletion, the queuing process will take log n percolate down process, right? And find maximum itself, the value, finding maximum value itself is actually order of 1. But the queuing process, to keep these tree structures and pip structures intact, it takes order of log n. Just seeing that value itself is order of 1, right? However, having said that, when we take this alternative build approach that we discussed in the later slide, it can improve this time complexity to the order of n. So build itself takes order of n, and in queuing process, still it takes log n percolate up, so order of log n, order of log n of the queue and itself, and order 1 to just see this highest priority, high maximum value here. So we can see that this order of n squared, order of n, has been improved in these binary heap structures, and this low order of n is now becoming order of log n. If you remember, this order of log n grows like this, and order of n grows like this. So order of log n always have a lower value than n, and that's actually the key of this performance upgrade improvement. And furthermore, what we can do here with this alternative build is that this build time, order of n, is actually very efficient. So what people thought about was, how about utilizing it in the sort process? So priority queue itself is getting the higher value than the lower value, higher priority value first, then the lower priority value later. In that case, why don't we repeat the dequeuing process with the highest value, dequeuing the maximum value itself? In that case, it's very well utilized for these sorting operations, right? Particularly, binary heap enables the dequeuing of the order of log n. And for dequeuing the all elements, it takes the order of log n. So we are going to dequeue the n items for the log n time, right? We are going to take n items for log n times, so it takes order of n log n. So we create this priority queue, and we keep taking the first value and dequeuing. And in that case, if that dequeuing process is very efficient, write this order of log n, then order of n log n is is going to be the sorting complexity of this process. If we think about selection, sort is actually order of n squared. Then order of n log n is way better than order of n squared. So learning time is going to be like this way. So we are going to take the heap sort based approach rather than selection sort based approach. So how to perform a sorting with this heap? First, given a list of index, first copy the whole value into the binary tree in an array, and then utilize the alternative build approach, right? And percolate down to the mix, index 0, and right. And then we take out one element at a time. It's going to be order of n log n. And if we have if we consider this alternative build approach, it's going to be order of n, so it doesn't affect to this complexity. So the heap sort is one of the low n log n based sorting method. And actually, in the merge sort that we discussed in the previous week, in the recursion week, merge sort is another algorithm of order of n log n approach. So further reading is here. So this is a very great book, and I recommend you to go home and read this textbook for the further instructions, right? So here, this is the whole source code of the binary heap, and I'd like you to type in this source codes, and that so that you can improve your programming skill. Also, you can understand better of this binary heap structure, right? So we have this build thing, and we have percolate down, and we have percolate up, and in queue and the queue process. Good. Right. Thanks for listening and have a good day.